Hello everyone. So the topic we'll be discussing today is function. Now what is a function? If there is a relation between input and output such that for every input you receive an output and that output is unique. That is, for no input you will receive more than one output. But for every input you will receive an output. Then that relation is said to be a function between input and output set. Now let's discuss functions with the help of sets. Now let's say I have two sets A and B, and A has elements 1, 2, 3, 4 and 5. B has elements X, Y, Z, U, V, W. Now for example, there is a relation between A and B which maps 1 to X, 2 to Y, 3 to Y, 4 to U, and let's say 5 to W. Now here, is this relation a function or not? This is the question. Now for a function, every element of a set should have an image. That is, look at this. Now 1 has its image as X, 2 has its image as Y, 3 also has its image as Y, but 3 has an image. Also 4 and 5 do have an image. So yes, this is a function. But what if I say there is an element in A, let's say 6, which does not maps to any element in B? Then this will not be a function, because there is an element in A which has no map in B. No mapping, that is no image in B. Then this mapping or this relation will not be a function. And what if I say there is an element in A, let's say 4 is an element which also maps to Z. Then also this relation will not be a function, because there is an element in A, that is 4. There is this element in A which is mapping to two elements. That is, there is this element in A, I am highlighting this, which is mapping to two elements in B. So this mapping is not a function. But if I take the initial case where each element of A has a unique image, then that relation is a function. Now let's revise this again. So if I have a map between two sets A and B, where A has elements 1, 2, 3, 4 and B has elements X, Y, Z, W, and every element of A is mapped to one element of B which is unique, then that is a function. That is, many to one will be a function. Now if I have A as 1, 2, 3, 4 and B has X, Y, Z, W, where 1 is mapped to X, 2 is mapped to Y, 3 is mapped to Z, and 4 is not mapped to any element in B. 4 is not mapped to any element in B. Then this is not a function, because every element must have an image. Again, if I have elements in A as 1, 2, 3 and 4 and elements in B as X, Y, Z and W, where one has image X and one has image Y, then this will not be a function, not a function. Why? Because 1 has more than one image, that is, the image is not unique. So let's discuss domain, codomain and range now. In general, we write a function as f of x, where for any value of x you get the image, and the image is f of x. Now consider these two sets, let's say A and B. A has all the values which x can take, let's say x1, x2 and x3. And B has the images of these values, that is fx1, fx2, fx3, and there is a function between A to B mapping. Then, and you have an element fx4, which is not the image of any other element, or you can also name it as y or any other element. And this is not the image of any element of A. Now x1, x2 and x3 are the values which x can take. And for these values you have images fx1, fx2 and fx3. So x1, x2 and x3 will be the domain of this function. That is, the values x can take will be the domain in a function. And fx1, fx2, fx3 are the values which are the images of these elements. These are the range of the function. Whereas a set of fx1, fx2, fx3 and y or fx4, that is the set B. This whole set is the codomain. Now let's do one example. Let's say I have f of x is equal to x square. Now is this a function or not? See, for define on R to R, that is real numbers. For every real number you will have a square, that is consider 1, then you have 1 square. For that is for any, in general, any real number, say x, you will have x square. So there is an image for every element. And although it is possible for elements to have same images, that is -1 square is also 1 and 1 square is also 1, but it is not possible that 1 square is 1 and also some other number. 1 square is only 1, that is you have unique image. So yes, this relation is a function. Also, if we see this with the help of a graph, the graph of f of x is equal to x square will be somewhat like this. And here, for every value of x, you will have an image, and that too unique. Now let's discuss another function, another relation which we have to see if it is a function or not. Let's say f of x is equal to root x is defined on all real numbers, two real numbers. Is it a function or not? So if you take f of x, if you take x as -1, you will get f of x is equal to under root -1, which is not a real number. That is, under root -1 does not belongs to R. So no, this is not a function. Also, if we plot f of x is equal to root x, where x goes from real numbers to real numbers where it is defined, then you will have a graph like this, and for no real negative values of x, there is a value of f of x. That is, for no real negative values of x, where x is real negative, there is no value of f of x. So no, this is not a function if you define it from real numbers to real numbers. So I hope this topic is clear to you. Please do like this video and subscribe to our channel. Thank you so much for watching.